The night sky stretches endlessly above us, a canvas of darkness punctuated by the soft glow of distant stars. But among those stars lie vast clouds of gas and dust, swirling with colors that seem almost otherworldly nebulae, the universe's most breathtaking masterpieces. Have you ever stopped to wonder what secrets these glowing clouds hold? What makes them so mesmerizing yet so dangerous? These celestial wonders are more than just stunning visuals. They are the birthplaces of stars, the remnants of dying giants, and regions of unimaginable power. But beneath their ethereal beauty lies a hidden danger, a reminder that the cosmos is as unpredictable as it is magnificent. Today, we'll journey through some of the most captivating and hazardous nebulas in the night sky. From stellar nurseries to explosive supernova remnants, these cosmic phenomena will leave you in awe of the universe's mysteries. So, let's dive into the heart of these glowing clouds and uncover the stories they tell, stories of creation, destruction, and the incredible forces that shape our universe. Nebulas are the universe's grand storytellers, vast clouds of gas and dust that stretch across the galaxy like cosmic brushstrokes. These clouds, often illuminated by the light of nearby stars or the aftermath of stellar explosions, are more than just stunning celestial sights. They are the lifeblood of the cosmos. Hidden within their swirling depths lies the raw material for new stars, planets, and even entire solar systems. They are both nurseries and graveyards, places where stars are born from chaos and where they return to dust after their fiery demise. But not all nebulas are the same. Some glow with vibrant colors like the emission nebulas, energized by the intense radiation of nearby stars. Others, known as reflection nebulas, shimmer softly as they scatter starlight, creating a ghostly, almost ethereal glow. And then there are the dark nebulas, mysterious and shadowy, blocking the light behind them like cosmic ink spilled across the stars. Each type tells a different story, shaped by its unique composition and the forces acting upon it. Yet, for all their beauty, these glowing clouds are not as serene as they appear. Within their depths, temperatures can plummet to near absolute zero or soar to unimaginable heights. Magnetic fields twist and churn, creating regions of intense turbulence. And in some cases, the very processes that give nebulas their mesmerizing glow can also unleash destructive forces. So, as we marvel at their splendor, let's not forget that these cosmic wonders are also places of immense power and danger, reminding us that the universe is as unpredictable as it is beautiful. The universe is an artist, and nebulas are its masterpieces. These vast clouds of gas and dust are painted across the night sky in hues that seem almost too vibrant to be real. Reds, blues, and purples swirl together in intricate patterns, creating a cosmic canvas that has captivated humanity for centuries. Take the Orion Nebula, for example. Just over 1,300 light-years away, it's one of the brightest and most studied nebulas in the sky. Its vibrant core glows with a mix of ionized hydrogen and oxygen, producing a fiery palette that feels almost alive. Then there's the Eagle Nebula, home to the iconic pillars of creation. These towering columns of gas and dust, immortalized by the Hubble Space Telescope, are a testament to the raw beauty and complexity of these celestial formations. But what gives nebulas their stunning colors? It's all about the interaction of light with the gases and dust within them. Emission nebulas, like the Orion Nebula, glow because the intense ultraviolet light from nearby stars energizes the gas, causing it to emit its own light. Reflection nebulas, on the other hand, don't produce their own light but scatter the light from nearby stars, creating softer, more ethereal hues. And then there are the dark nebulas, which absorb light, appearing as shadowy silhouettes against the brighter backdrop of space. Telescopes like Hubble have brought these details to life, revealing textures and structures that were once invisible to the naked eye. these celestial wonders have inspired more than just astronomers. Artists, writers, and dreamers have long been drawn to the beauty of nebulas, seeing them as symbols of creation, mystery, and the infinite. The swirling colors and shapes have sparked imaginations, from the surreal paintings of Vincent van Gogh to the awe-inspiring visuals of modern science fiction. But while nebulas are undeniably beautiful, they are also places of incredible energy and activity. Beneath their serene appearance lies a world of chaos and transformation, where stars are born and die in spectacular fashion. As we marvel at the artistry of these cosmic clouds, it's worth remembering that their beauty is just one side of the story. The same forces that create these stunning visuals can also unleash unimaginable power, shaping the universe in ways that are as destructive as they are creative. So, while we gaze at the Orion Nebula or the pillars of creation, let's not forget the darker, more turbulent side of these celestial wonders, a side that reminds us just how dynamic and unpredictable the cosmos truly is. Nestled within the sword of the mighty Orion constellation, the Orion Nebula stands as one of the most iconic and studied regions of the night sky. Just over 1,300 light-years from Earth, this glowing cloud of gas and dust is a bustling hub of cosmic activity. But it's not just its striking beauty that makes it a favorite among astronomers, it's what's happening inside. The Orion Nebula is a stellar nursery, a place where stars are born from the chaos of swirling gas and dust. Within its vibrant core, young stars ignite, their intense radiation and powerful stellar winds carving out intricate structures in the surrounding gas. These forces don't just shape the nebula's appearance, they also play a crucial role in its evolution. The radiation ionizes the hydrogen gas, causing it to glow with the iconic reddish hue we associate with the Orion Nebula. Meanwhile, the stellar winds push and sculpt the gas into towering pillars and delicate filaments, creating a landscape that feels almost alive. But this process isn't without its dangers. The same forces that give the nebula its glow and shape also have the power to disrupt and destroy. Young stars, still in their formative stages, are bombarded by intense radiation that can strip away their protoplanetary disks, the material from which planets might one day form. In some cases, entire planetary systems could be obliterated before they even have a chance to take shape. It's a reminder that the Orion Nebula, for all its beauty, is a place of both creation and destruction. What makes the Orion Nebula particularly fascinating is its accessibility. Visible to the naked eye under dark skies, it's been a source of wonder for centuries. Early astronomers, armed with nothing more than simple telescopes, marveled at its glow. Today, with advanced instruments like the Hubble Space Telescope, we can peer deep into its heart, uncovering details that were once hidden from view. We've discovered protostars still wrapped in their dusty cocoons, jets of material streaming from newborn stars, and vast clouds of gas being shaped by the relentless forces at play. The Orion Nebula serves as a vivid reminder of the dual nature of nebulas. They are places of incredible beauty and immense power, where the forces of creation and destruction are intertwined. As we continue to study this cosmic nursery, we gain not only a deeper understanding of how stars and planets form, but also a greater appreciation for the delicate balance that shapes the universe. The Orion Nebula is more than just a glowing cloud in the night sky. It's a window into the dynamic and often turbulent processes that drive the cosmos. And as we explore further, we'll see that this duality isn't unique to the Orion Nebula. Across the galaxy, nebulas play a dual role, acting as both the birthplace of stars and the stage for their dramatic ends. They are cosmic storytellers, weaving tales of creation, destruction, and the incredible forces that shape the universe. The Eagle Nebula is a cosmic marvel that has captured the imagination of stargazers and scientists alike. Located about 7,000 light-years from Earth, this glowing expanse of gas and dust is perhaps best known for its breathtaking pillars of creation. These towering structures, immortalized by the Hubble Space Telescope, rise like colossal sentinels against the backdrop of space, their intricate shapes sculpted by the forces of nature. But what makes these pillars so extraordinary isn't just their appearance, it's what's happening within them. Deep inside these massive columns, new stars are being born. The dense clouds of gas and dust provide the raw material for stellar formation, collapsing under their own gravity to ignite the fires of young stars. It's a process that can take millions of years, a slow but relentless dance of creation. The pillars of creation are, in many ways, the ultimate cosmic nursery, a place where the universe's next generation of stars begins its journey. Yet, even as these pillars give life to new stars, they are also being slowly eroded by the very forces they help create. The intense radiation from nearby young stars bombards the structures, stripping away layers of gas and dust. This process, known as photoevaporation, is gradually wearing down the pillars, carving them into the intricate shapes we see today. Over time, this relentless erosion will cause the pillars to disintegrate entirely, a reminder that even the most enduring cosmic structures are not immune to the forces of destruction. This paradox of creation and destruction lies at the heart of the Eagle Nebula's story. The same radiation that tears apart the pillars also plays a crucial role in triggering the formation of new stars. As the intense light pushes against the gas and dust, it compresses the material, creating pockets dense enough to collapse and ignite. In this way, the Eagle Nebula is a place where destruction fuels creation, where the end of one structure marks the beginning of something new. The pillars of creation are more than just a stunning sight. They are a snapshot of the universe's endless cycle of birth and death. They remind us that the cosmos is a dynamic, ever-changing place where beauty and chaos exist side by side. As we marvel at these towering columns, we are witnessing not just the birth of stars, but also the delicate balance that governs the universe. But while the Eagle Nebula is a place of stellar beginnings, not all nebulas share this role. Some are the remnants of stellar death, the final chapters in the lives of massive stars. These nebulas, born from the explosive ends of supernova or the gentle shedding of outer layers by dying stars, tell a different story, one of endings rather than beginnings. And as we turn our gaze to these cosmic remnants, we'll see how the universe continues to transform, even in the face of destruction. Among the countless nebulas that adorn the night sky, few are as iconic or as explosive as the Crab Nebula. This swirling cloud of gas and dust, located about 6,500 light-years away in the constellation Taurus, is the aftermath of one of the most dramatic events in the cosmos, a supernova. In the year 1054, observers on Earth witnessed a new star shining brighter than Venus in the daytime sky. Chinese, Japanese, and Arab astronomers recorded the event, describing it as a guest star that outshone everything but the moon. What they were seeing was the violent death of a massive star, an explosion so powerful that its light reached Earth across the vast expanse of space. Today, the remnants of that explosion form the Crab Nebula, a chaotic web of filaments and glowing gas. At its heart lies one of the most fascinating objects in the universe, a pulsar. This rapidly spinning neutron star, no larger than a city, emits beams of radiation that sweep across space like a cosmic lighthouse. The pulsar's intense magnetic field and rapid rotation generate powerful jets of particles and radiation, energizing the surrounding nebula and giving it its distinctive glow. But the Crab Nebula is more than just a stunning sight. It's a reminder of the immense power of supernova, events that can outshine entire galaxies. These explosions are not only spectacular but also incredibly hazardous. The high-energy particles and radiation emitted by supernova remnants like the Crab Nebula can travel vast distances, posing risks to any nearby star systems. In fact, if a supernova were to occur too close to Earth, its radiation could strip away our planet's ozone layer, exposing life on the surface to harmful ultraviolet rays from the Sun. The Crab Nebula's pulsar also serves as a cosmic laboratory, offering scientists a unique opportunity to study the extreme conditions found in neutron stars. Its intense magnetic fields and rapid rotation create environments that are impossible to replicate on Earth, allowing researchers to test theories about the behavior of matter under such extreme pressures. As we gaze at the Crab Nebula, we're not just looking at the remains of a long-dead star. We're witnessing the aftermath of a cosmic event that shaped the universe in profound ways. Supernovae are responsible for creating many of the heavy elements that make up our world, from the iron in our blood to the gold in our jewelry. Without these explosive deaths, life as we know it might not exist. The Crab Nebula's story doesn't end with its chaotic beauty or its pulsar's relentless energy. It's a testament to the universe's cycle of destruction and renewal, where the end of one star marks the beginning of countless new possibilities. And as we turn our attention to other nebulas born from stellar explosions, we'll see how these cosmic events continue to shape the galaxy, leaving behind remnants that are as dangerous as they are dazzling. Each one tells a story of creation and chaos, a reminder that even in the vastness of space, nothing is ever truly still. The Veil Nebula is a masterpiece of cosmic destruction, a sprawling remnant of a supernova explosion that tore through the galaxy thousands of years ago. Located about 2,400 light-years from Earth in the constellation Cygnus, this vast cloud of gas and dust stretches across an area of the sky 6 times the width of the full moon. Its intricate, lace-like filaments glow in vivid hues of red, blue, and green, creating a celestial tapestry that seems almost too delicate to be real. But don't let its beauty fool you. The Veil Nebula is a testament to the raw power of a star's explosive death. When a massive star exhausts its nuclear fuel, it collapses under its own gravity before rebounding in a cataclysmic supernova. The shock waves from this explosion rip through space at incredible speeds, heating and compressing the surrounding gas. Over time, these shock waves sculpt the debris into the intricate filaments we see today, a process that continues even now, thousands of years after the initial explosion. The Veil Nebula's delicate strands are not static. They are dynamic, ever-changing structures shaped by the relentless forces of the cosmos. But these shock waves are more than just beautiful, they are also incredibly dangerous. As they expand outward, they carry with them intense radiation and high-energy particles that can wreak havoc on any star system in their path. Planets caught in the crossfire could face devastating consequences, from the stripping of their atmospheres to the bombardment of their surfaces with lethal radiation. It's a reminder that the universe, for all its splendor, is a place of immense volatility, where even the most distant events can have far-reaching effects. The Veil Nebula's beauty lies not just in its appearance but also in what it reveals about the universe. By studying its filaments, astronomers can piece together the story of the supernova that created it, learning about the star's life, its explosive end, and the impact it had on its surroundings. The nebula's glowing gases act as a cosmic fingerprint, encoding information about the elements forged in the star's core and scattered into space by the explosion. These elements, from oxygen to silicon, are the building blocks of planets, moons, and even life itself. As we marvel at the Veil Nebula's intricate design, it's worth reflecting on the delicate balance that governs the universe. The same forces that create such breathtaking beauty can also unleash unimaginable destruction. The Veil Nebula is a vivid reminder of this duality, a cosmic tapestry woven from the threads of creation and chaos. Yet, not all nebulas are as relatively benign as the Veil. Some are actively hazardous to their surroundings, regions of space where the very processes that give them life also make them deadly. These nebulas, born from the most violent events in the universe, serve as a stark reminder that the cosmos is as dangerous as it is beautiful. From their turbulent origins to their destructive potential, they challenge us to see the universe not just as a place of wonder, but also as a realm of profound and often perilous complexity. Deep within the southern skies lies a celestial giant, a nebula so vast and turbulent that it dwarfs even the Orion Nebula in size and activity, the Carina Nebula. Spanning over 300 light-years and located approximately 7,500 light-years from Earth, this colossal star factory is one of the most dynamic regions in our galaxy. It's a place where stars are born on an epic scale, their births accompanied by violent outbursts of radiation and stellar winds that shape the surrounding gas and dust into dramatic, otherworldly landscapes. At the heart of the Carina Nebula lies Eta Carinae, a hypergiant star so massive and unstable that it defies imagination. Eta Carinae is estimated to be over 100 times the mass of our Sun, and its luminosity is millions of times greater. This star is a ticking time bomb, prone to massive eruptions that have already blasted away vast amounts of material, creating the stunning homunculus nebula that surrounds it. But Eta Carinae's most dramatic act may still lie ahead. When it eventually explodes as a supernova, the energy released could rival the brightness of an entire galaxy, a cosmic event of unparalleled intensity. The Carina Nebula's massive stars don't just create breathtaking visuals, they also wield immense power. The intense ultraviolet radiation they emit ionizes the surrounding gas, causing it to glow in vivid reds and blues. But this radiation is a double-edged sword. While it illuminates the nebula, it also has the potential to strip away the atmospheres of any planets orbiting nearby stars. Imagine a world where the skies are torn away, leaving the surface exposed to the harshness of space. This is the reality for any planetary systems unlucky enough to be too close to these stellar giants. But the danger doesn't stop there. The Carina Nebula is home to numerous other massive stars, each capable of going supernova. When one of these stars reaches the end of its life, the resulting explosion would send shock waves rippling through the nebula, compressing gas and triggering the formation of new stars while obliterating others. The sheer scale of these events is staggering, a reminder that the universe operates on a level of energy and destruction far beyond human comprehension. What makes the Carina Nebula particularly fascinating is its dual nature. It's both a place of creation and destruction, where the forces that give life to stars also have the power to annihilate them. This duality is a hallmark of many nebulas, but few exemplify it as dramatically as Carina. It's a cosmic crucible where the raw materials of the universe are forged into stars and planets, only to be torn apart and reshaped by the very processes that brought them into being. As we explore the Carina Nebula, it's impossible not to marvel at its beauty and complexity. Yet, it also serves as a stark reminder of the hazards that lurk within the cosmos. The same processes that create the stunning visuals we admire can also unleash forces capable of reshaping entire star systems. This tension between creation and destruction is at the heart of the universe's story, a narrative written in gas, dust, and light. And as we turn our gaze to other nebulas, we'll see that this theme repeats itself across the galaxy. From the explosive remnants of supernova to the turbulent nurseries of new stars, nebulas are places of immense power and peril. They are the universe's way of reminding us that beauty and danger often go hand in hand, a lesson written across the night sky for all who care to look. The Tarantula Nebula, a name that evokes both awe and a hint of trepidation, is one of the most extreme environments in the known universe, located in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. This colossal nebula spans over 600 light-years and is a hotbed of stellar activity. If the Carina Nebula is a star factory, the Tarantula Nebula is its hyperactive cousin, churning out stars at a rate that defies imagination. Its core is a maelstrom of radiation, stellar winds, and massive stars, each one a titan in its own right. At the heart of the Tarantula Nebula lies R136, a cluster of stars so dense and luminous that it's almost hard to believe. Within this cluster are some of the most massive stars ever discovered, each burning through its fuel at an astonishing rate. These stars are not just large, they are colossal, with masses hundreds of times greater than our Sun and luminosities millions of times brighter. Their intense radiation floods the surrounding space, ionizing gas and sculpting the nebula into intricate, web-like structures that give the tarantula its name. But this radiation isn't just a source of light, it's a force of destruction. The ultraviolet light emitted by these massive stars is so powerful that it can strip away the atmospheres of any planets that might form nearby. Imagine a world where the very air is torn away, leaving the surface exposed to the harshness of space. This is the reality for any planetary systems unlucky enough to emerge in the Tarantula Nebula. The stellar winds from these massive stars add another layer of danger. These winds, composed of charged particles streaming out from the stars at incredible speeds, carve out vast cavities in the surrounding gas, creating shock waves that ripple through the nebula. These shock waves can trigger the formation of new stars, but they can also obliterate existing structures, tearing apart clouds of gas and dust before they have a chance to collapse into stars. Despite these hazards, the Tarantula Nebula plays a crucial role in shaping its corner of the universe. The intense activity within the nebula drives the evolution of the Large Magellanic Cloud, enriching it with heavy elements forged in the cores of its massive stars. When these stars eventually go supernova, they scatter these elements into space, seeding the galaxy with the building blocks of planets, moons, and even life. The Tarantula Nebula is a galactic powerhouse, a place where the universe flexes its creative and destructive muscles on a scale that's hard to comprehend. Its extreme environment is a reminder that the cosmos is not just a place of beauty, but also one of immense power and volatility. As we move from the Tarantula Nebula to other regions of the galaxy, we'll explore nebulas that tell a different story, one of endings rather than beginnings. These nebulas, born from the final acts of dying stars, are monuments to the universe's relentless cycle of creation and destruction. Each one holds clues to the lives and deaths of the stars that shaped them, offering a glimpse into the forces that continue to shape the cosmos. The Helix Nebula is a hauntingly beautiful reminder of what lies ahead for stars like our own. Located about 700 light-years from Earth in the constellation Aquarius, this planetary nebula earned its nickname, the Eye of God, for its striking resemblance to a cosmic eye gazing out into the void. Its eerie, layered rings of gas and dust tell the story of a star's final act, a slow and dramatic shedding of its outer layers as it transitions into the next phase of its existence. At the center of the Helix Nebula lies a white dwarf, the dense, glowing core of what was once a sun-like star. As the star exhausted its nuclear fuel, it swelled into a red giant, its outer layers drifting away into space. Over thousands of years, these layers formed the intricate, glowing rings we see today. But the white dwarf isn't just a quiet remnant, it emits intense ultraviolet radiation, a byproduct of its searing heat. This radiation ionizes the surrounding gas, causing it to glow in vivid reds and blues, creating the nebula's ghostly, eye-like appearance. The Helix Nebula isn't just a visual marvel, it's also a cautionary tale for any planetary systems that might have once orbited its central star. As the star expanded and shed its outer layers, it would have engulfed any nearby planets, stripping them of their atmospheres and leaving behind barren, lifeless husks. Even planets farther out wouldn't have been safe. The white dwarf's intense ultraviolet radiation continues to bombard the surrounding space, making it a hostile environment for any remaining worlds. This process isn't unique to the Helix Nebula. Planetary nebulas like it are scattered throughout the galaxy, each one the final chapter in the life of a star similar to our Sun. They serve as a stark reminder of the impermanence of stellar systems, including our own. In about 5 billion years, our Sun will follow a similar path, expanding into a red giant and eventually leaving behind a white dwarf surrounded by its own planetary nebula. But not all nebulas announce their presence so vividly. While the Helix Nebula is a glowing spectacle, others remain hidden from view, invisible to the naked eye and detectable only through specialized instruments. These nebulas, often shrouded in dust or composed of gases that don't emit visible light, reveal a different side of the cosmos, one that challenges our understanding and pushes the boundaries of exploration. As we turn our attention to these unseen wonders, we'll uncover the secrets they hold, from the birth of stars in dense molecular clouds to the enigmatic remnants of long-dead giants. While they may lack the visual spectacle of the Helix Nebula, their stories are no less profound, offering a glimpse into the quieter, yet equally dynamic corners of the universe. While many nebulas dazzle us with their glowing colors and intricate structures, not all cosmic clouds are so easy to see. Dark nebulas, the shadowy counterparts to their brighter siblings, are vast regions of space where dense clouds of gas and dust block the light of stars and galaxies behind them. These cosmic veils, often appearing as inky black patches against the starry backdrop, are more than just empty voids. They are active, dynamic regions where the universe's most fundamental processes unfold. Dark nebulas are like celestial fog, so dense that not even the brightest stars can pierce through them. Take the famous Horsehead Nebula, for example. This iconic formation, silhouetted against the glowing gas of the Orion Nebula, is one of the most recognizable dark nebulas in the night sky. Its distinctive shape, resembling a horse's head, is carved out by the interplay of light and shadow, a reminder of how these dark clouds can transform the appearance of the cosmos. But dark nebulas are more than just cosmic scenery. They play a crucial role in the birth of stars. Within their dense interiors, temperatures can plummet to near absolute zero, creating the perfect conditions for gas and dust to clump together. Over time, these clumps grow denser, eventually collapsing under their own gravity to ignite the fires of new stars. In this way, dark nebulas are the hidden nurseries of the universe, places where the raw materials of future solar systems are gathered and shaped. Yet, for all their creative potential, dark nebulas also pose significant challenges. Their dense clouds can obscure entire regions of the sky, making it difficult for astronomers to study the stars and galaxies hidden behind them. For spacecraft navigating through the galaxy, these dark clouds present a navigational hazard, their thick dust and gas potentially interfering with instruments and sensors. Imagine trying to pilot a ship through a dense fog, unable to see what lies ahead. This is the reality for any mission passing through the heart of a dark nebula. What makes dark nebulas particularly mysterious is their ability to hide their secrets. Unlike emission or reflection nebulas, which glow with the light of nearby stars, dark nebulas reveal little about their inner workings. They are cosmic enigmas, their depth shrouded in shadow and silence. Yet, even in their darkness, they hold clues to the universe's most profound questions, from the origins of stars to the complex chemistry of space. As we peer into these shadowy regions, we begin to see how they fit into the larger story of the cosmos. Dark nebulas are not just obstacles or voids. They are active participants in the universe's ongoing cycle of creation and transformation. And as we turn our attention to nebulas shaped by magnetic fields, we'll discover yet another layer of complexity, one where invisible forces sculpt the gas and dust into breathtaking, otherworldly forms. These magnetic fields, often overlooked in the grand spectacle of the cosmos, play a vital role in shaping the structure and behavior of nebulas. From twisting filaments to intricate loops, they leave their mark on the fabric of space, reminding us that the universe is as much about the unseen as it is about the visible. And as we explore these magnetic nebulas, we'll uncover yet another piece of the cosmic puzzle, one that reveals the delicate interplay of forces that shape the stars and galaxies we admire. The Horsehead Nebula is one of the most iconic images in astronomy, a shadowy silhouette that seems to leap out of the glowing gas of the Orion Nebula. Its unmistakable shape, resembling a horse's head, has made it a favorite among stargazers and scientists alike. But what exactly is this cosmic landmark, and why does it captivate us so deeply? This dark nebula, located about 1,500 light-years from Earth, is a dense cloud of gas and dust so thick that it blocks the light from the bright emission nebula behind it. The Horsehead's distinctive shape is carved out by the intense radiation from nearby stars, which erodes the edges of the cloud, creating its signature profile. The glowing red background caused by ionized hydrogen contrasts sharply with the nebula's Inkai silhouette, making it a striking visual spectacle. Studying the Horsehead Nebula, however, is no easy task. Its dense clouds absorb not just visible light, but also much of the infrared and radio wavelengths that astronomers use to peer into its depths. This makes it a challenging target for observation, requiring advanced instruments and techniques to uncover its secrets. Despite these difficulties, researchers have managed to map its structure and composition, revealing a complex interplay of gas, dust, and magnetic fields. But the Horsehead Nebula isn't just a beautiful cosmic portrait, it's also a reminder of the challenges posed by dark nebulas. These dense regions of space can obscure entire star systems, making it difficult to study the objects hidden within or behind them. For spacecraft traveling through the galaxy, dark nebulas present a navigational hazard, their thick clouds of dust potentially interfering with instruments and sensors. Imagine trying to navigate through a dense fog, unable to see what lies ahead. This is the reality for any mission passing through the heart of a dark nebula. Despite these challenges, dark nebulas like the Horsehead play a crucial role in the life cycle of stars. They are cosmic cradles, places where gas and dust come together to form the seeds of new stars and planets. Over time, gravity pulls these materials into dense clumps, which eventually collapse to ignite the fires of stellar birth. In this way, the Horsehead Nebula is not just a cosmic icon, it's a testament to the universe's endless cycle of creation and transformation. As we marvel at the Horsehead Nebula's beauty and complexity, it's worth considering how other forces shape the cosmos. Beyond the interplay of light and shadow lies another invisible sculptor, magnetic fields. These powerful forces, though unseen, leave a profound mark on the structure and behavior of nebulas, twisting gas and dust into intricate, otherworldly forms. And as we turn our attention to these magnetic nebulas, we'll uncover yet another layer of the universe's incredible complexity, where invisible forces shape the stars and galaxies we admire. Magnetic fields are the invisible architects of the cosmos, weaving their influence through the vast clouds of gas and dust that form nebulas. While we often focus on the light and color of these celestial wonders, it's the magnetic fields, unseen but omnipresent, that shape their most intricate and dynamic features. Picture these fields as cosmic threads, twisting and stretching through space, guiding the flow of gas and dust into elaborate patterns. They are the hidden force behind the delicate filaments, swirling loops, and towering pillars that define so many nebulas. Take, for example, the intricate tendrils seen in the Veil Nebula. These delicate, lace-like structures aren't just the result of shock waves from a supernova explosion, they're also shaped by the magnetic fields threading through the gas. These fields act like invisible scaffolding, channeling and organizing the flow of material into the stunning patterns we observe. Without them, the nebula's chaotic aftermath might have formed a far less structured and far less beautiful remnant. But magnetic fields do more than just create aesthetic patterns. They also play a critical role in regulating the movement of gas and dust within nebulas. In regions where stars are forming, magnetic fields can slow down the collapse of gas clouds, acting as a kind of cosmic brake. This process allows the gas to clump together more gradually, forming denser cores that eventually ignite into new stars. In this way, magnetic fields are not just passive bystanders, they're active participants in the birth of stars and planetary systems. These fields also have a protective side. Nebulas are often filled with high-energy particles and radiation, remnants of the violent processes that created them. Magnetic fields can trap and redirect this radiation, creating pockets of relative calm within the chaos. This shielding effect is particularly important in regions where young stars are forming, as it can help preserve the delicate protoplanetary disks that may one day give rise to planets. Yet, for all their benefits, magnetic fields can also be a source of danger. In some cases, they can become tightly wound and unstable, releasing bursts of energy that ripple through the nebula. These magnetic storms can disrupt the formation of stars or even tear apart existing structures, adding another layer of complexity to the life cycle of nebulas. As we delve deeper into the role of magnetic fields, it's impossible not to marvel at their dual nature. They are both creators and destroyers, shaping the cosmos with a delicate balance of order and chaos. But magnetic fields aren't the only invisible forces at work in the universe. In certain regions of space, another powerful influence takes center stage: black holes. These enigmatic objects, with their immense gravitational pull, can dramatically alter the behavior of nebulas, creating environments unlike anything else in the cosmos. As we turn our attention to nebulas shaped by black holes, we'll see how these gravitational giants leave their mark on the fabric of space, sculpting gas and dust into structures that are as mesmerizing as they are mysterious. The interplay between black holes and nebulas is a story of extreme forces and dramatic transformations, one that reveals yet another layer of the universe's incredible complexity. Black holes, the universe's most enigmatic powerhouses, are not just cosmic vacuums, they are also sculptors of some of the most extreme and fascinating nebulas in existence. Near these gravitational giants, the rules of physics bend, and the environment becomes a chaotic dance of intense radiation, swirling gas, and unimaginable forces. Nebulas that form in the vicinity of black holes are unlike any others, shaped by the relentless pull and push of gravity and light in ways that defy our understanding. One of the most striking examples is the nebula surrounding the supermassive black hole at the center of our galaxy, Sagittarius A. This swirling cloud of gas and dust is caught in a cosmic tug of war, with the black hole's immense gravity pulling material inward while its radiation pushes outward. The result is a turbulent, high-energy environment where gas is heated to millions of degrees, glowing brightly in X-rays and other wavelengths invisible to the human eye. These nebulas are not just beautiful, they are dynamic and dangerous, with radiation levels so intense that they could strip away the atmospheres of any planets unfortunate enough to orbit nearby stars. But the dangers don't stop at radiation. The gravitational forces near black holes are so extreme that they can tear apart entire star systems. Stars that venture too close are stretched and shredded in a process called spaghettification, their remains forming swirling disks of gas around the black hole. These accretion disks, glowing with the heat of friction and compression, are the birthplaces of some of the most energetic nebulas in the universe. The material in these disks doesn't just sit idly, it spirals inward, releasing bursts of energy that can illuminate the surrounding space for light years. What makes these nebulas particularly intriguing is their role in shaping the evolution of galaxies. The energy and material ejected by black holes can trigger the formation of new stars even as they destroy others. In this way, black holes are both creators and destroyers, their influence rippling through the cosmos in ways that are still not fully understood. Yet, not all black hole-influenced nebulas are visible in the light we can see. Some are shrouded in dust or emit radiation at wavelengths that require specialized instruments to detect. These hidden nebulas reveal a different side of the universe, one where the interplay of gravity, light, and magnetic fields creates environments that challenge our imagination. As we explore these extreme environments, it's worth considering how much of the universe remains hidden from our view. Nebulas that glow in visible light are just the tip of the cosmic iceberg. Beyond them lie regions of space that can only be seen in infrared, radio, or X-ray wavelengths, each offering a unique glimpse into the universe's most dynamic processes. This brings us to the next chapter of our journey, nebulas visible only in specific wavelengths. These hidden wonders, invisible to the naked eye, hold secrets that redefine our understanding of the cosmos. From the birth of stars in dense molecular clouds to the remnants of ancient supernova, they remind us that the universe is far more complex and far more beautiful than we can ever fully comprehend. Beyond the vibrant colors and glowing clouds of visible nebulas lies a hidden world, one that can only be seen through the lens of infrared light. These infrared nebulas, shrouded in thick clouds of dust, remain invisible to the naked eye and even to traditional optical telescopes. Yet, within their shadowy depths, some of the universe's most fascinating processes are unfolding. Infrared telescopes like NASA's Spitzer Space Telescope and the James Webb Space Telescope have peeled back the veil of dust to reveal these cosmic secrets, showing us a side of the cosmos we might otherwise never have known existed. Take, for example, the Orion Molecular Cloud Complex. While the Orion Nebula dazzles us with its bright emission clouds, the surrounding region is cloaked in dense dust, hiding the birthplaces of countless stars. Infrared imaging pierces through this dust, exposing a bustling stellar nursery teeming with protostars, young stars still wrapped in their dusty cocoons. These images reveal intricate filaments of gas and dust, swirling and collapsing under gravity's pull, offering us a front-row seat to the earliest stages of star formation. But why are these nebulas so shrouded in dust? The answer lies in their origins. Many infrared nebulas form in regions where massive stars have recently exploded as supernova or shed their outer layers. The debris from these events, dust and gas, scatters throughout the surrounding space, creating thick clouds that block visible light. Yet, infrared light, with its longer wavelengths, can pass through this dust, allowing us to see what lies beneath. The science behind this is as fascinating as the images themselves. Infrared telescopes detect the heat emitted by dust and gas, which absorbs energy from nearby stars and re-emits it as infrared radiation. This process not only reveals the hidden structures of these nebulas, but also provides clues about their temperature, composition, and dynamics. For astronomers, it's like opening a treasure chest of data, offering insights into how stars and planetary systems form in these obscured environments. However, these hidden nebulas are far from serene. The same dust that obscures them also acts as a trap for intense radiation. Within these clouds, young stars emit powerful ultraviolet light, which heats the surrounding dust and gas to extreme temperatures. This radiation can strip away the atmospheres of nearby planets, making it nearly impossible for life to take hold. Even more dramatically, the pressure from this radiation can compress gas clouds, triggering the birth of new stars while simultaneously eroding the structures around them. Infrared nebulas remind us that the universe is full of surprises hidden in plain sight. They challenge our understanding of star formation and the life cycles of nebulas, offering a glimpse into the invisible forces that shape the cosmos. As we move from these dust-shrouded regions, we encounter another powerful force shaping nebulas: stellar winds. These torrents of charged particles streaming from the surfaces of massive stars carve out vast cavities in the surrounding gas and dust, sculpting nebulas into breathtaking and often chaotic forms. The interplay between stellar winds and nebulas is a story of creation and destruction, one that reveals yet another layer of the universe's incredible complexity. Stellar winds are the cosmic sculptors of the universe, carving out the intricate shapes and structures we see in nebulas. These winds, composed of charged particles streaming from the surfaces of massive stars, are more than just a byproduct of stellar activity. They are powerful forces that shape the very fabric of space. Imagine a star so massive and luminous that its energy doesn't just radiate outward in light. It also propels particles at incredible speeds, creating a relentless torrent of wind that can reshape entire regions of a nebula. One of the most dramatic examples of stellar winds at work can be found in the Carina Nebula. Here, the intense radiation and winds from stars like Eta Carinae blast through the surrounding gas and dust, carving out vast cavities and towering pillars. The process is both creative and destructive. On one hand, these winds compress the gas, triggering the formation of new stars. On the other, they erode existing structures, stripping away material and leaving behind a landscape of sculpted gas and dust. But stellar winds aren't just shaping nebulas, they're also creating hazards for nearby star systems. The high-energy particles streaming from these winds can bombard planets, stripping away their atmospheres and exposing their surfaces to harmful radiation. For any planetary systems unlucky enough to be in the path of these winds, the consequences can be devastating. It's a reminder that the universe, for all its beauty, is a place of immense power and volatility. Another striking example of stellar winds in action is the Omega Nebula, also known as M17. This sprawling cloud of gas and dust, located about 5,500 light-years from Earth, is being sculpted by the winds of young, massive stars at its core. These winds push outward, creating shock waves that ripple through the nebula and shape its glowing filaments. The result is a dynamic, ever-changing environment where the forces of creation and destruction are locked in a delicate balance. As we explore these wind-sculpted nebulas, it's impossible not to marvel at the sheer power of stellar winds. They remind us that the universe is not a static place, but a dynamic, ever-evolving system where stars and nebulas are constantly shaping and reshaping one another. Yet, not all nebulas owe their structure to the winds of single stars. Some are shaped by the complex interactions of binary star systems, where two stars orbit each other in a cosmic dance. These systems, with their intricate gravitational pulls and shared stellar winds, create nebulas that are as unique as they are beautiful. And as we turn our attention to these binary remnants, we'll see how the interplay of two stars can leave a lasting mark on the cosmos, shaping nebulas in ways that are as fascinating as they are complex. In the vast expanse of the cosmos, some of the most intriguing nebulas are born not from the actions of a single star, but from the intricate dance of two. Binary star systems, where two stars orbit a shared center of gravity, create nebulas that are as unique as they are mesmerizing. These celestial duos, bound together by gravity, often leave behind stunning remnants shaped by their mutual interactions, stellar winds, gravitational tugs, and the occasional explosive finale. Take, for instance, the Cat's Eye Nebula. This planetary nebula, located about 3,300 light-years from Earth, is believed to have been shaped by a binary star system. At its core, a dying star and its companion, possibly a white dwarf, spun around each other, their gravitational forces sculpting the surrounding gas into intricate rings and jets. The result is a nebula that resembles a cosmic eye, its layered structure a testament to the complex interplay of two stars. But the story of binary star nebulas doesn't end with their beauty. These systems are often volatile, with the potential for catastrophic outcomes. When one star in a binary system exhausts its nuclear fuel, it can collapse into a dense white dwarf or explode as a supernova, depending on its mass. If the stars are close enough, the explosion can strip material from the surviving companion, creating a nebula rich in heavy elements forged in the heart of the dying star. The dangers don't stop there. Binary systems can also give rise to some of the most energetic events in the universe, such as gamma-ray bursts. These brief but intense flashes of radiation, produced when a massive star collapses or two neutron stars merge, can outshine entire galaxies for a moment. Any nearby nebula caught in the blast would be bathed in lethal radiation, its gas and dust ionized and scattered across space. What makes binary star nebulas particularly fascinating is their ability to tell the story of stellar relationships. The gravitational forces between the two stars create intricate patterns in the surrounding gas, from swirling spirals to delicate jets. These structures are not just beautiful, they are also clues to the history of the system, offering insights into the star's masses, orbits, and eventual fates. Yet, binary star systems are not the only cosmic partnerships that shape nebulas. In some cases, the influence of supermassive stars, stars so large and luminous that they dwarf even the most massive binary systems, can create nebulas on an entirely different scale. These stellar giants, with their immense radiation and powerful stellar winds, leave behind remnants that are as awe-inspiring as they are hazardous. As we turn our gaze to these supermassive stars and the nebulas they create, we'll see how the universe's most extreme environments continue to challenge our understanding of cosmic processes. From their turbulent births to their explosive deaths, these stars remind us that the cosmos is a place of both beauty and danger, where the forces of creation and destruction are forever intertwined. Supermassive stars are the titans of the cosmos, celestial behemoths that dwarf even the most massive stars we've encountered so far. These giants, often hundreds of times more massive than our Sun, are rare but immensely influential, shaping the nebulas around them with their staggering energy output and violent lives. Their radiation is so intense that it can ionize gas across vast distances, creating nebulas that glow with an almost ethereal brilliance. Yet, for all their luminosity, these stars are also harbingers of destruction, their immense power posing significant hazards to any nearby star systems. The nebulas surrounding supermassive stars are unlike any others. Take, for example, the Tarantula Nebula's R136 cluster, home to some of the most massive stars known. These stars emit ultraviolet radiation so powerful that it can strip away the atmospheres of planets light years away. The surrounding nebula, a chaotic web of gas and dust, is sculpted by their stellar winds, which blast through the region at speeds of millions of kilometers per hour. These winds carve out vast cavities, triggering the formation of new stars while simultaneously eroding existing structures. But the life of a supermassive star is a short and fiery one. Burning through their fuel at an astonishing rate, these stars live fast and die young. When they exhaust their nuclear fuel, their cores collapse, triggering a supernova explosion that can outshine an entire galaxy. The aftermath is a nebula rich in heavy elements, forged in the heart of the dying star and scattered across space. These remnants, like the Crab Nebula, are not just beautiful, they are the building blocks of future stars, planets, and even life itself. However, the end of a supermassive star's life isn't always marked by a supernova. Some of these giants collapse directly into black holes, their immense gravity consuming everything around them. In these cases, the surrounding nebula may be swept into the black hole's accretion disk, creating a glowing halo of gas and dust that spirals inward, releasing bursts of energy as it goes. The influence of supermassive stars extends far beyond their immediate surroundings. Their intense radiation and powerful winds can trigger star formation in distant regions of a nebula, while their explosive deaths seed the galaxy with the elements necessary for life. Yet, their presence is a double-edged sword. While they drive the evolution of the cosmos, they also create environments that are hostile to life as we know it. As we shift our focus from these cosmic giants, we encounter another phenomenon that shapes nebulas in dramatic and often devastating ways: gamma-ray bursts. These brief but intense flashes of radiation, some of the most energetic events in the universe, leave behind nebulas that are as mysterious as they are beautiful. The interplay between these bursts and the surrounding gas and dust reveals a universe that is far more dynamic and far more dangerous than we often imagine. Gamma-ray bursts are the universe's most violent spectacles, brief but unimaginably powerful flashes of energy that can outshine entire galaxies for a few fleeting seconds. These cosmic explosions, often triggered by the collapse of massive stars or the collision of neutron stars, are among the most energetic events ever observed. Yet, their brilliance comes at a cost. Gamma-ray bursts don't just light up the cosmos. They also leave behind a trail of destruction, reshaping the nebulas they encounter and posing existential threats to any life unlucky enough to be nearby. When a gamma-ray burst occurs, it sends a concentrated beam of high-energy radiation shooting through space at nearly the speed of light. If a nebula lies in its path, the results can be catastrophic. The intense radiation ionizes the gas, stripping electrons from atoms and heating the material to extreme temperatures. This process can trigger shock waves that ripple through the nebula, compressing gas and dust into new structures while obliterating others. In some cases, the burst's energy is so immense that it can completely disrupt the nebula's delicate balance, scattering its material across vast distances. But the dangers of gamma-ray bursts extend far beyond their impact on nebulas. Any star system within range of these bursts, even those thousands of light-years away, could face devastating consequences. The intense radiation can strip away planetary atmospheres, exposing surfaces to lethal levels of ultraviolet light and cosmic rays. For any life forms on these planets, the aftermath of a gamma-ray burst would be nothing short of apocalyptic. It's a sobering reminder that the universe, for all its beauty, is also a place of unimaginable peril. Yet, despite their destructive power, gamma-ray bursts play a crucial role in the cosmos. The heavy elements they produce, elements like gold, platinum, and uranium, are scattered into space, enriching the surrounding nebulas and providing the raw materials for future stars and planets. In this way, gamma-ray bursts are both destroyers and creators, their explosive energy reshaping the universe in profound and lasting ways. As we reflect on the immense power of gamma-ray bursts, it's worth considering how much of the universe remains hidden from our view. These events, though fleeting, leave behind nebulas that tell the story of their explosive origins. Yet not all nebulas are born from such violent beginnings. Some are the remnants of ancient stars, their quiet deaths giving rise to structures that are as serene as they are beautiful. These nebulas, born from the gentle shedding of a star's outer layers, offer a stark contrast to the chaos of gamma-ray bursts. They remind us that the universe is not just a place of destruction, but also one of quiet transformation, where even the end of a star's life can create something new and enduring. As we explore these comma remnants, we'll see how the universe continues to evolve, weaving its stories of creation and change through the delicate interplay of gas, dust, and light. Ancient nebulas are like cosmic time capsules, preserving the secrets of the universe's infancy. These remnants of some of the earliest stars offer a rare glimpse into a time when the cosmos was young, filled with raw energy and the first glimmers of light. Unlike the vibrant, glowing nebulas we see today, these ancient clouds are often faint and elusive, their light having traveled billions of years to reach us. Yet, within their delicate filaments and fading structures, they hold clues to the origins of everything we know. One of the most fascinating aspects of these ancient nebulas is their unique composition. The earliest stars, known as population Roman III stars, were made almost entirely of hydrogen and helium, the simplest elements forged in the Big Bang. When these stars died, they seeded the universe with heavier elements like carbon, oxygen, and iron, which now form the building blocks of planets, life, and even the nebulas we see today. Studying these ancient clouds allows astronomers to piece together the story of how the first stars lived, died, and transformed the cosmos into the rich, diverse place it is now. But peering into the past comes with its challenges. The light from these ancient nebulas is incredibly faint, stretched and dimmed by the expansion of the universe over billions of years. To study them, astronomers rely on some of the most advanced telescopes ever built, like the James Webb Space Telescope, which can detect the faint infrared glow of these distant clouds. Even then, the data is often sparse and difficult to interpret, requiring painstaking analysis to separate the signal from the noise. Adding to the complexity is the fact that these nebulas are often shrouded in mystery. Many are located in regions of the universe where dark matter, the invisible substance that makes up most of the cosmos, exerts a powerful influence. This unseen force shapes the distribution of gas and dust, influencing how ancient nebulas form and evolve. While dark matter itself doesn't emit light, its gravitational pull can bend and distort the light from these nebulas, creating ghostly halos and intricate patterns that hint at its presence. Studying these ancient nebulas is like trying to read a faded, centuries-old manuscript. Each clue, each faint trace of light, brings us closer to understanding the universe's earliest chapters. Yet, the hazards of this journey are real. The immense distances involved mean that the light we observe is billions of years old, making it difficult to know what these nebulas look like today, or if they even still exist. As we explore these relics of the past, we're reminded that the universe is not just a place of beauty, but also one of profound mystery. The same forces that shaped the first stars and nebulas continue to shape the cosmos today, weaving a story that spans billions of years and countless generations of stars. And as we turn our attention to nebulas influenced by dark matter, we'll see how this invisible force not only shapes the universe's history but also its future, guiding the evolution of nebulas in ways we are only beginning to understand. Dark matter is one of the greatest mysteries of the cosmos, an invisible force that shapes the universe on a scale we can barely comprehend. Though it doesn't emit, absorb, or reflect light, its gravitational pull is undeniable, weaving its influence through galaxies and nebulas alike. This unseen substance, which makes up about 85% of all matter in the universe, plays a crucial role in how nebulas form, evolve, and interact with their surroundings. Even though we can't see dark matter directly, its fingerprints are everywhere, from the delicate filaments of gas and dust to the vast structures that stretch across the cosmos. Take, for instance, the way dark matter influences the formation of nebulas in galaxy clusters. These massive collections of galaxies are held together by dark matter's gravitational pull, creating a cosmic scaffolding that shapes the distribution of gas and dust. Within these clusters, nebulas often form in the dense regions where dark matter's gravity compresses the material, triggering the birth of stars. The result is a delicate interplay between the visible and invisible, where dark matter guides the growth of nebulas without ever revealing itself. But studying nebulas influenced by dark matter is no easy task. Since dark matter doesn't interact with light, astronomers must rely on indirect methods to detect its presence. One common technique is gravitational lensing, where the immense gravity of dark matter bends the light from distant nebulas, creating distorted or magnified images. These lensing effects allow scientists to map the distribution of dark matter, revealing how it shapes the nebulas around it. Yet, even with these tools, much about dark matter remains shrouded in mystery, leaving us to piece together its role in the cosmos through careful observation and deduction. The challenges don't end there. Dark matter's influence extends far beyond the visible structures of nebulas, affecting their motion and evolution over time. In some cases, dark matter can even create environments where nebulas form in unexpected ways, such as in the faint, diffuse clouds that drift between galaxies. These so-called intergalactic nebulas, often invisible to traditional telescopes, are shaped by the gravitational pull of dark matter, showing us just how far its influence reaches. As we explore these dark matter-driven nebulas, we're reminded of how much of the universe remains hidden from our view. The interplay between dark matter and visible gas and dust is a testament to the complexity of the cosmos, where the seen and unseen work together to create the structures we admire. Yet, dark matter isn't the only force shaping nebulas in dramatic ways. Across the universe, collisions between galaxies and other cosmic events leave their mark, creating nebulas that are as chaotic as they are beautiful. These cosmic collisions, with their immense energy and turbulence, remind us that the universe is a place of constant change, where even the most delicate structures are shaped by forces far beyond our control. When galaxies collide, the universe puts on a breathtaking show, a spectacle of cosmic fireworks that lights up the darkness with swirling clouds of gas, dust, and stars. These collisions, though incredibly rare in human terms, are a driving force behind some of the most dramatic and visually stunning nebulas in the cosmos. As galaxies spiral together, their immense gravitational forces pull and twist the gas and dust within them, creating vast, chaotic regions where new stars are born and old ones meet their fiery ends. The result is a celestial ballet of creation and destruction, where nebulas emerge as glowing remnants of these cosmic encounters. One of the most striking examples is the Antennae galaxies, a pair of colliding galaxies located about 60 million light-years from Earth. As these galaxies merge, their interstellar gas and dust are compressed, triggering bursts of star formation that light up the surrounding space. The nebulas born from this collision glow in vibrant hues of red, blue, and gold, their intricate shapes sculpted by the tidal forces of the merging galaxies. Yet, this beauty comes with a price. The intense radiation from newly formed stars and the shock waves from supernova explosions create hazardous environments for any nearby star systems. Planets caught in the crossfire could face devastating consequences, from the stripping of their atmospheres to the bombardment of their surfaces with lethal radiation. Another fascinating example is the Cartwheel Galaxy, a ring-shaped galaxy formed by a high-speed collision with a smaller companion. The impact sent shock waves rippling through the galaxy, compressing gas and dust into a glowing ring of star-forming regions. These nebulas, illuminated by the light of young stars, are a testament to the immense energy released during galactic collisions. Yet, they also serve as a reminder of the turbulence that accompanies such events. The Cartwheel Galaxy's ring is a cosmic battlefield where the forces of creation and destruction are locked in a delicate balance. Colliding nebulas aren't just beautiful, they're also laboratories for understanding the universe. These events provide astronomers with a unique opportunity to study how stars and planets form under extreme conditions. The intense pressures and temperatures created by galactic collisions can trigger the formation of stars much larger and more energetic than those found in quieter regions of the galaxy. These massive stars, in turn, shape the nebulas around them, creating structures that are as dynamic as they are dazzling. But the hazards of colliding nebulas extend beyond their immediate surroundings. The shock waves and radiation produced by these events can ripple through the galaxy, influencing the evolution of star systems far from the collision site. In some cases, these effects can even trigger star formation in distant regions, creating a chain reaction that reshapes the galaxy over millions of years. As we marvel at these cosmic fireworks, it's worth considering how the universe's most dramatic events continue to shape the cosmos. Colliding nebulas are a vivid reminder that the universe is a place of constant change, where even the most delicate structures are shaped by forces far beyond our control. And as we shift our gaze from these galactic collisions, we encounter another cosmic force that shapes nebulas in equally dramatic ways: pulsars. These rapidly spinning neutron stars, born from the explosive deaths of massive stars, leave behind nebulas that are as mesmerizing as they are mysterious. Their influence, though less visible than the chaos of galactic collisions, is no less profound, weaving its way through the fabric of space in ways that challenge our understanding of the cosmos. Pulsars are the universe's cosmic lighthouses, spinning neutron stars that beam intense radiation across space at incredible speeds. But these rapid spinners don't just light up the cosmos, they also shape some of the most dynamic and hazardous nebulas in existence. Known as pulsar wind nebulas, these glowing clouds are sculpted by the relentless energy of pulsars, creating structures that are as mesmerizing as they are dangerous. At the heart of a pulsar wind nebula lies a pulsar, the dense remnant of a massive star that exploded in a supernova. As the pulsar spins, it emits jets of high-energy particles and radiation known as a pulsar wind. This wind streams outward at nearly the speed of light, colliding with the surrounding gas and dust. The result is a glowing nebula. Its intricate filaments and shock waves are testament to the pulsar's immense power. One of the most famous examples is the Crab Nebula, a pulsar wind nebula born from a supernova observed on Earth in the year 1054. At its center, the Crab pulsar spins 30 times per second, its rapid rotation generating a powerful wind that energizes the surrounding nebula. The Crab's filaments glow with the light of ionized gas, while its jets of particles create intricate patterns that ripple through the cloud. Yet, this beauty comes with a price. The pulsar's intense radiation and high-energy particles make the Crab Nebula a hazardous environment for any nearby star systems. But pulsar wind nebulas aren't just beautiful remnants of stellar explosions, they also play a crucial role in the universe. The high-energy particles they emit can trigger the formation of new stars even as they erode existing structures. In this way, pulsars are both creators and destroyers, their winds shaping the cosmos in ways that are still not fully understood. Another remarkable example is the Veil pulsar and its associated nebula. Located about 800 light-years from Earth, the Veil pulsar spins 11 times per second, its wind carving out a glowing cloud of gas and dust. The nebula's intricate filaments are a testament to the pulsar's power, while its shock waves ripple through the surrounding space, compressing gas and triggering new waves of star formation. Yet, the hazards of pulsar wind nebulas extend far beyond their immediate surroundings. The intense radiation emitted by pulsars can strip away the atmospheres of planets light years away, making these regions hostile to life as we know it. Even more dramatically, the high-energy particles streaming from pulsars can disrupt the delicate balance of interstellar gas, triggering turbulence that ripples through entire galaxies. As we explore these cosmic powerhouses, it's worth considering how their influence extends beyond the visible structures they create. Pulsar wind nebulas are not just remnants of stellar death. They are active participants in the universe's ongoing cycle of creation and destruction. And as we turn our gaze to another cosmic force, quasars, we'll see how these enigmatic objects shape nebulas in equally dramatic ways, weaving their influence through the fabric of space and time. Quasar nebulas are cosmic beacons, glowing with a brilliance that defies imagination. These luminous clouds of gas and dust are shaped by quasars' supermassive black holes at the centers of distant galaxies, devouring matter at an astonishing rate. As material spirals into the black hole, it heats up and releases bursts of energy so intense that they outshine entire galaxies. The surrounding nebulas, bathed in this searing light, glow with a radiance that can be seen across billions of light years. Yet, for all their brilliance, these nebulas are also some of the most hazardous environments in the universe. The radiation emitted by quasars is unlike anything else in the cosmos. Ultraviolet and X-ray light flood the surrounding space, ionizing gas and stripping electrons from atoms. This process heats the nebulas to extreme temperatures, creating environments where the very fabric of matter is altered. For any star systems unlucky enough to be nearby, the consequences are dire. Planetary atmospheres can be stripped away, leaving surfaces exposed to lethal levels of radiation. Even the gas and dust within the nebulas themselves are not immune, as the intense energy from the quasar carves out vast cavities and shapes the surrounding material into intricate glowing filaments. Yet, quasars are not just destructive forces. They play a crucial role in shaping the evolution of their host galaxies and the nebulas within them. The energy they release can compress gas clouds, triggering the formation of new stars. In this way, quasars act as cosmic architects, their immense power driving the birth of stars and planetary systems even as they tear apart existing structures. It's a delicate balance, one that highlights the dual nature of these luminous giants, both creators and destroyers on a galactic scale. The influence of quasars extends far beyond their immediate surroundings. Their intense radiation can travel vast distances, illuminating and energizing nebulas in far-flung regions of the galaxy. These interactions create some of the most dynamic and visually stunning structures in the universe, from glowing halos to swirling jets of gas. Yet, they also remind us of the immense power wielded by these cosmic beacons, a power that can both illuminate and obliterate. As we explore these quasar-driven nebulas, it's worth considering how their influence shapes the universe on a larger scale. The energy they release can trigger waves of star formation, enriching galaxies with the heavy elements needed for planets and life. At the same time, their radiation can create environments so hostile that even the hardiest life forms would struggle to survive. This duality is a hallmark of quasars, a reminder that the universe is a place of both beauty and danger, where the forces of creation and destruction are forever intertwined. But quasars are not the only cosmic forces that shape nebulas in dramatic ways. Across the universe, another phenomenon leaves its mark: cosmic jets. These narrow streams of charged particles ejected from the cores of galaxies carve out vast structures in the surrounding gas and dust, creating nebulas that are as mesmerizing as they are mysterious. The interplay between these jets and the nebulas they encounter reveals yet another layer of the universe's incredible complexity, where invisible forces sculpt the cosmos in ways that challenge our understanding. Cosmic jets are the universe's high-speed sculptors, narrow beams of charged particles that race through space at nearly the speed of light. Ejected from the cores of black holes or neutron stars, these jets are among the most energetic phenomena in the cosmos, capable of carving out vast structures in the surrounding gas and dust. Where they collide with nebulas, the results are nothing short of spectacular and often destructive. These jets don't just shape the nebulas they encounter, they transform them, creating environments that are as hazardous as they are mesmerizing. One of the most striking examples is the nebula surrounding the black hole at the center of the galaxy Messier 87. This supermassive black hole, famous for being the first ever imaged, emits a jet that stretches for thousands of light years. As the jet plows through the surrounding gas, it creates shock waves that heat the material and compress it into glowing filaments. The result is a nebula that glows with the light of ionized gas, its intricate structures a testament to the immense power of cosmic jets. Yet, this beauty comes at a cost. The high-energy particles streaming from the jet can strip away the atmospheres of any planets in their path, leaving behind barren, lifeless worlds. Another remarkable example is the nebula surrounding the neutron star SS 433. This system, located about 18,000 light-years from Earth, emits jets that twist and spiral through space, creating a nebula that resembles a cosmic tornado. The jet's rapid motion and intense energy heat the surrounding gas, causing it to glow in vivid colors. But these jets are more than just visually stunning, they're also incredibly dangerous. The radiation they emit can disrupt the delicate balance of interstellar gas, triggering turbulence that ripples through the nebula and beyond. The influence of cosmic jets extends far beyond their immediate surroundings. The shock waves they create can compress gas clouds, triggering the formation of new stars even as they erode existing structures. In this way, cosmic jets are both creators and destroyers, their immense power shaping the cosmos in ways that are still not fully understood. Yet, cosmic jets aren't the only forces that leave their mark on nebulas. Across the universe, another phenomenon shapes these glowing clouds in equally dramatic ways: supernova shock waves. These powerful ripples of energy, born from the explosive deaths of massive stars, can reshape entire regions of space, creating nebulas that are as turbulent as they are beautiful. As we turn our attention to these shock wave-driven nebulas, we'll see how the universe's most violent events continue to shape the cosmos, weaving a story of creation and destruction that spans billions of years. Supernova shock waves are the universe's ultimate disruptors, rippling through space with enough energy to reshape entire regions of a nebula. When a massive star reaches the end of its life and explodes as a supernova, the resulting shock waves tear through the surrounding gas and dust, compressing it into intricate, glowing structures. These waves aren't just destructive, they're also creative, triggering the birth of new stars while obliterating existing ones. It's a cosmic paradox where destruction fuels creation, and the aftermath of a star's death becomes the birthplace of something new. Take, for example, the Cygnus Loop, a sprawling supernova remnant located about 2,400 light-years from Earth. This vast, filamentary nebula is the aftermath of a stellar explosion that occurred between 10 and 20,000 years ago. The shock waves from that explosion are still rippling through space, compressing gas into delicate, lace-like patterns that glow with the light of ionized hydrogen. Yet, for all its beauty, the Cygnus Loop is a hazardous environment. The intense radiation and high-energy particles unleashed by the supernova can strip away the atmospheres of any nearby planets, leaving behind barren, lifeless worlds. Another striking example is the Veil supernova remnant, located about 800 light-years from Earth. This glowing cloud of gas and dust is the aftermath of a supernova that exploded around 11,000 years ago. The shock waves from that explosion have sculpted the surrounding nebula into intricate filaments and bubbles, creating a celestial tapestry that glows with the light of ionized gas. But the Veil supernova remnant isn't just a beautiful sight. It's also a reminder of the immense power of supernova explosions. The radiation and high-energy particles released by these events can travel vast distances, posing significant hazards to any star systems in their path. The influence of supernova shock waves extends far beyond their immediate surroundings. These waves can trigger the formation of new stars, even as they tear apart existing structures. In some cases, the shock waves from a supernova can compress gas clouds, creating regions dense enough to collapse and ignite the fires of stellar birth. This process, known as triggered star formation, is a testament to the dual nature of supernova destroyers that also create, reshaping the cosmos in profound and lasting ways. Yet, the hazards of supernova shock waves are not limited to their immediate impact. The radiation and high-energy particles they release can ripple through the galaxy, influencing the evolution of star systems far from the explosion site. In some cases, these effects can even trigger waves of star formation in distant regions, creating a chain reaction that reshapes the galaxy over millions of years. As we marvel at the intricate structures shaped by supernova shock waves, it's worth considering how these cosmic ripples fit into the larger story of the universe. They remind us that the cosmos is a place of constant change, where even the most violent events can give rise to new beginnings. And as we turn our gaze to nebulas shaped by stellar collisions, we'll see how the universe's most dramatic encounters continue to shape the cosmos, weaving a story of creation and destruction that spans billions of years. Stellar collisions are another force that leaves its mark on the universe, creating nebulas that are as chaotic as they are beautiful. Imagine two massive stars locked in a gravitational dance, their immense gravity pulling them closer and closer until they collide in a fiery explosion. The resulting nebula, a swirling cloud of gas and dust, is a testament to the immense energy released during such a collision. These nebulas, shaped by the forces of gravity and radiation, are some of the most dynamic and visually stunning structures in the cosmos. As we explore these collision-driven nebulas, we'll uncover yet another layer of the universe's incredible complexity, where the forces of creation and destruction are forever intertwined. The interplay between these forces reminds us that the cosmos is not just a place of beauty, but also one of immense power and volatility, where even the most delicate structures are shaped by forces far beyond our control. Stellar collisions are the universe's ultimate cosmic showdowns, where two massive stars, locked in a gravitational embrace, meet in a fiery explosion that reshapes the fabric of space. These cataclysmic events don't just end with a bang, they leave behind glowing nebulas, swirling clouds of gas and dust that tell the story of their violent origins. Imagine two titans of the cosmos, each hundreds of times more massive than our Sun, spiraling toward each other until they collide in a burst of energy so immense it can outshine entire galaxies. The aftermath is a nebula unlike any other, a chaotic masterpiece of creation and destruction. One of the most dramatic examples of a collision-driven nebula is the Red Square Nebula, a glowing cloud of gas and dust shaped by the merger of two massive stars. Located about 5,000 light-years from Earth, this nebula's intricate, almost symmetrical structure is a testament to the immense forces at play during the collision. The resulting shock waves ripple through the surrounding space, compressing gas and triggering the birth of new stars even as they obliterate existing structures. Yet, for all its beauty, the Red Square Nebula is also a reminder of the hazards posed by stellar collisions. The intense radiation and high-energy particles unleashed during such events can strip away the atmospheres of nearby planets, leaving behind barren, lifeless worlds. But stellar collisions aren't just destructive, they're also creative. The energy released during these events can compress gas clouds, triggering waves of star formation that ripple through the galaxy. In some cases, the material ejected during a collision can form protoplanetary disks, the seeds of future solar systems. This duality, creation and destruction, is a hallmark of stellar collisions, a reminder that even the most violent events in the cosmos can give rise to new beginnings. Another striking example is the collision-driven nebula surrounding the star system V838 Monocerotes. In 2002, astronomers observed this system undergoing a dramatic outburst, its brightness increasing by a factor of 10,000 in just a few weeks. The cause, a collision between two stars or perhaps a star and a massive planet. The resulting nebula, illuminated by the light of the outburst, is a glowing cloud of gas and dust that continues to expand into space, its intricate filaments a testament to the forces unleashed during the collision. As we marvel at these collision-driven nebulas, it's worth considering how their influence extends far beyond their immediate surroundings. The shock waves and radiation produced by stellar collisions can ripple through the galaxy, triggering star formation in distant regions and reshaping the cosmic landscape over millions of years. These nebulas are not just beautiful remnants of stellar violence, they are active participants in the universe's ongoing cycle of creation and destruction. Yet, the universe's drama doesn't end with stellar collisions. In some of the most extreme environments, another phenomenon takes center stage: gamma-ray bursts. These brief but unimaginably powerful flashes of energy, often triggered by the collapse of massive stars or the collision of neutron stars, leave behind nebulas that are as mysterious as they are mesmerizing. As we shift our gaze to these gamma-ray burst-driven nebulas, we'll uncover yet another layer of the universe's incredible complexity, where the forces of creation and destruction are forever intertwined. Gamma-ray bursts are like the universe's ultimate fireworks brief, blinding flashes of energy that light up the cosmos for mere seconds but leave a lasting impact. These cataclysmic events, often triggered by the collapse of massive stars or the collision of neutron stars, are among the most powerful explosions ever observed. When a gamma-ray burst occurs, it sends a concentrated beam of high-energy radiation tearing through space, leaving a trail of destruction in its wake. Nebulas caught in the path of these bursts don't just glow, they are fundamentally transformed, their delicate structures reshaped by the immense energy unleashed during these cosmic catastrophes. The effects of a gamma-ray burst on a nebula are nothing short of catastrophic. The intense radiation ionizes the gas, stripping electrons from atoms and heating the material to extreme temperatures. This process triggers shock waves that ripple through the nebula, compressing gas and dust into new structures while obliterating others. In some cases, the burst's energy is so immense that it can completely disrupt the nebula's delicate balance, scattering its material across vast distances. For any star systems within range, the consequences are dire. The intense radiation can strip away planetary atmospheres, exposing surfaces to lethal levels of ultraviolet light and cosmic rays. It's a sobering reminder of the destructive power wielded by these cosmic explosions. Yet, gamma-ray bursts are not just agents of destruction, they also play a crucial role in the universe's ongoing cycle of creation and renewal. The heavy elements forged in the heart of the collapsing star, elements like gold, platinum, and uranium, are scattered into space, enriching the surrounding nebulas and providing the raw materials for future stars and planets. In this way, gamma-ray bursts are both destroyers and creators, their explosive energy reshaping the cosmos in profound and lasting ways. The long-term effects of gamma-ray bursts extend far beyond their immediate surroundings. The shock waves they produce can trigger waves of star formation in distant regions of a nebula, creating a chain reaction that reshapes the cosmic landscape over millions of years. Even the radiation they emit can influence the evolution of star systems far from the explosion site, altering the chemical composition of gas clouds and driving the formation of new structures. In this way, gamma-ray bursts are not just fleeting events, they are cosmic architects, their influence rippling through the universe long after the initial flash has faded. As we reflect on the immense power of gamma-ray bursts, it's worth considering how much of the universe remains hidden from our view. These events, though fleeting, leave behind nebulas that tell the story of their explosive origins. Yet, not all nebulas are shaped by such violent beginnings. Some are influenced by a force even more mysterious and pervasive: dark energy. This invisible force, which makes up about 70% of the universe, is responsible for the accelerated expansion of the cosmos. While dark energy doesn't directly shape nebulas in the same way as gamma-ray bursts or stellar winds, its influence is felt on the largest scales, driving the expansion of space itself. Nebulas, like everything else in the universe, are caught in this cosmic tide, their structures subtly stretched and reshaped over billions of years. As we turn our attention to the interplay between dark energy and nebulas, we'll see how this enigmatic force leaves its mark on the cosmos, shaping the universe in ways that are as profound as they are invisible. The story of nebulas is not just one of light and color. It's also a story of the unseen forces that guide their evolution, weaving a narrative that spans the entirety of space and time. Dark energy is the universe's silent architect, an invisible force that shapes the cosmos on the grandest of scales. Though it doesn't glow like stars or swirl like nebulas, its presence is undeniable, stretching the fabric of space itself and influencing everything within it. This mysterious force, which makes up about 70% of the universe, is responsible for the accelerated expansion of the cosmos. While it doesn't directly sculpt nebulas in the way gravity or radiation does, its influence is felt everywhere, guiding the large-scale distribution of galaxies, clusters, and the glowing clouds of gas and dust that connect them. So, how does dark energy affect nebulas? Imagine the universe as a vast, ever-expanding canvas. Nebulas, like brushstrokes on this canvas, are carried along by the stretching of space. Over billions of years, dark energy pushes galaxies and their surrounding nebulas farther apart, creating a cosmic tapestry that grows ever larger and more diffuse. This expansion doesn't just move nebulas, it also affects their visibility and structure. As space stretches, the light from distant nebulas is stretched too, shifting toward longer, redder wavelengths in a phenomenon known as redshift. For astronomers, this means that some of the most distant nebulas are not only harder to see, but also appear fainter and more spread out than they would in a static universe. Studying nebulas in an expanding universe comes with its own set of challenges. The farther away a nebula is, the more its light is stretched and dimmed, making it difficult to observe in detail. Even with the most advanced telescopes, capturing the faint glow of these distant clouds requires painstaking effort and innovative techniques. Adding to the complexity is the fact that dark energy's influence grows stronger over time, meaning that as the universe expands, nebulas are being pulled apart at an ever-increasing rate. This cosmic tug of war between gravity, which pulls matter together, and dark energy, which pushes it apart, creates a delicate balance that shapes the evolution of nebulas on a grand scale. Yet, for all its challenges, the study of dark energy and nebulas offers profound insights into the nature of the cosmos. By mapping the distribution of nebulas across vast distances, astronomers can trace the effects of dark energy, piecing together the story of how the universe has expanded over billions of years. These glowing clouds of gas and dust scattered across the night sky are more than just celestial wonders. They are cosmic signposts, guiding us toward a deeper understanding of the forces that shape our universe. As we peer into the vast expanse of space, it's worth considering how dark energy's influence extends beyond the visible structures of nebulas. The same force that drives the expansion of the universe also played a crucial role in its earliest moments during a period known as cosmic inflation. This rapid expansion, which occurred just fractions of a second after the Big Bang, set the stage for the formation of galaxies, stars, and the nebulas we admire today. As we transition to explore nebulas shaped by cosmic inflation, we'll uncover how these ancient forces continue to shape the cosmos, weaving a story that stretches from the universe's fiery beginnings to the glowing clouds that light up the night sky. The interplay between dark energy, inflation, and the structures they create is a testament to the universe's incredible complexity, a story that reminds us just how much there is still to discover. In the earliest moments of the universe, long before galaxies or stars existed, the cosmos underwent a rapid and dramatic expansion known as cosmic inflation. This fleeting but transformative period, occurring just fractions of a second after the Big Bang, set the stage for the formation of everything we see today, including nebulas. These ancient clouds of gas and dust, born in the fiery aftermath of inflation, hold clues to the universe's infancy, offering a rare glimpse into a time when the cosmos was young, chaotic, and brimming with raw energy. The nebulas that formed during this era are unlike anything we see in the modern universe. Back then, the universe was a dense, seething sea of particles, with temperatures so extreme that matter and energy were almost indistinguishable. As inflation stretched space itself, tiny fluctuations in density were magnified, creating regions where gas and dust could clump together. These dense pockets became the seeds of the first nebulas, glowing clouds that would eventually give rise to stars and galaxies. Yet, studying these ancient nebulas is no easy task. Their light has traveled billions of years to reach us, stretched and dimmed by the expansion of the universe. To detect their faint glow, astronomers rely on some of the most advanced telescopes ever built, like the James Webb Space Telescope, which can peer into the infrared wavelengths where these ancient clouds shine brightest. What makes these ancient nebulas so fascinating is their unique composition. Unlike modern nebulas, which are rich in heavy elements like carbon and oxygen, the earliest nebulas were made almost entirely of hydrogen and helium, the simplest elements forged in the Big Bang. This pristine gas provides a snapshot of the universe before stars had a chance to enrich it with heavier elements. By studying these ancient clouds, astronomers can piece together the story of how the first stars and galaxies formed, shedding light on one of the most mysterious chapters in cosmic history. But the challenges of studying these ancient nebulas are immense. Their light is incredibly faint, stretched by the expansion of space into wavelengths that are difficult to detect. Adding to the complexity is the fact that these nebulas are often shrouded in the cosmic fog of the early universe, a dense haze of gas that blocks much of their light. To peer through this fog, astronomers use techniques like gravitational lensing, where the gravity of massive galaxy clusters bends and magnifies the light from distant objects, bringing these ancient nebulas into view. As we explore these relics of the early universe, it's worth considering how they fit into the larger story of the cosmos. The nebulas born during cosmic inflation were the first steps in a journey that would eventually lead to the stars, galaxies, and planets we see today. Yet their story doesn't end there. These ancient clouds are also shaped by forces that are still at work in the universe, including the mysterious influence of dark matter. Dark matter, an invisible substance that makes up most of the matter in the universe, played a crucial role in shaping the first nebulas. Its gravitational pull guided the clumping of gas and dust, creating the dense regions where stars and galaxies could form. Even today, dark matter continues to shape the evolution of nebulas, weaving its influence through the cosmos in ways that are still not fully understood. As we turn our attention to nebulas shaped by dark matter, we'll see how this invisible force leaves its mark on the universe, from the delicate filaments of gas and dust to the vast structures that stretch across the cosmos. The interplay between dark matter and nebulas is a testament to the universe's incredible complexity. where the seen and unseen work together to create the structures we admire. The story of nebulas is not just one of light and color. It's also a story of the unseen forces that guide their evolution, weaving a narrative that spans the entirety of space and time. From the fiery beginnings of cosmic inflation to the invisible influence of dark matter, these glowing clouds remind us that the universe is full of mysteries waiting to be uncovered. Dark matter may be invisible, but its influence on the cosmos is unmistakable. This mysterious substance, which makes up about 85% of all matter in the universe, doesn't interact with light, making it impossible to see directly. Yet, its gravitational pull is everywhere, shaping the galaxies and nebulas we admire. Think of dark matter as the hidden scaffolding of the universe, a cosmic framework that guides the formation and evolution of these glowing clouds of gas and dust. Without it, the intricate structures of nebulas, from their delicate filaments to their sprawling shapes, simply wouldn't exist. The role of dark matter in shaping nebulas is both subtle and profound. In regions where dark matter is concentrated, its gravity pulls gas and dust together, compressing it into dense clouds that can ignite the birth of stars. These dense pockets of material become the seeds of nebulas, glowing with the light of ionized gas as new stars form. But dark matter doesn't just create nebulas, it also influences their behavior over time. Its gravitational pull can shape the motion of gas and dust within a nebula, guiding the flow of material and sculpting it into intricate patterns. One of the most fascinating aspects of dark matter is how it interacts with the visible universe. While we can't see dark matter directly, its presence can be inferred through its gravitational effects. For example, when light from a distant nebula passes through a region rich in dark matter, the light is bent and distorted, a phenomenon known as gravitational lensing. This cosmic trick of the light allows astronomers to map the distribution of dark matter, revealing how it shapes the nebulas we observe. Yet, for all its influence, dark matter remains one of the universe's greatest mysteries. Scientists still don't know what dark matter is made of, or how it interacts with ordinary matter beyond gravity. Its invisible nature makes it a challenging subject to study, requiring innovative techniques and cutting-edge technology to uncover its secrets. Despite these challenges, the search for dark matter continues, driven by the hope that understanding this elusive substance could unlock some of the deepest mysteries of the cosmos. As we explore the interplay between dark matter and nebulas, it's worth considering how this invisible force shapes not just individual nebulas but the entire universe. Dark matter's gravitational pull guides the formation of galaxies and the large-scale structure of the cosmos, creating a cosmic web of gas and dust that stretches across billions of light years. In this way, dark matter is more than just a hidden force. It's a fundamental part of the universe's story, one that continues to shape the cosmos in ways we are only beginning to understand. But dark matter isn't the only invisible force at work in the universe. Another powerful influence, equally mysterious but far more energetic, also leaves its mark on nebula's cosmic rays. These high-energy particles, streaming through space at nearly the speed of light, collide with the gas and dust within nebulas, creating intricate patterns and triggering waves of star formation. The interplay between cosmic rays and nebulas is a story of energy and transformation, one that reveals yet another layer of the universe's incredible complexity. As we turn our attention to these cosmic ray-driven nebulas, we'll see how the universe's most energetic particles shape the glowing clouds we admire, weaving a tale of creation and destruction that spans the cosmos. From their mysterious origins to their dramatic effects, cosmic rays remind us that the universe is a place of both beauty and danger, where even the smallest particles can have a profound impact on the largest structures. Cosmic rays are the universe's invisible power players, high-energy particles racing through space at nearly the speed of light. These particles, born from the explosive deaths of stars or the violent hearts of black holes, don't just travel aimlessly, they collide with the gas and dust of nebulas, leaving behind a trail of energy and transformation. But while cosmic rays might sound like something out of a science fiction story, their effects on nebulas are very real and often hazardous. These particles don't just shape the glowing clouds we admire, they can also unleash destructive forces that ripple through entire regions of space. When cosmic rays collide with the gas and dust within a nebula, they ionize the material, stripping electrons from atoms and heating the gas to extreme temperatures. This process can trigger shock waves that ripple through the nebula, compressing gas and dust into new structures while obliterating others. In some cases, these shock waves can even trigger the birth of new stars, creating pockets of dense material that collapse under their own gravity. Yet, for all their creative potential, cosmic rays also pose significant risks. The intense radiation they produce can strip away the atmospheres of nearby planets, exposing surfaces to lethal levels of ultraviolet light and cosmic rays. For any star systems unlucky enough to be in the path of these particles, the consequences can be dire. One striking example of a nebula shaped by cosmic rays is the Cygnus Loop, a sprawling supernova remnant located about 2,400 light-years from Earth. The shock waves from the supernova that created this nebula are still rippling through space, compressing gas and dust into delicate, glowing filaments. Yet, these shock waves are also energized by cosmic rays, which collide with the surrounding material and heat it to extreme temperatures. The result is a nebula that glows with the light of ionized gas. Its intricate structures are testament to the immense power of these high-energy particles. But cosmic rays aren't just shaping nebulas, they're also shaping our understanding of the universe. By studying the effects of cosmic rays on nebulas, astronomers can piece together the story of how these particles travel through space and interact with the material they encounter. This research offers insights into the origins of cosmic rays, as well as the processes that drive the evolution of nebulas and the star systems within them. As we explore these cosmic ray-driven nebulas, it's worth considering how their influence extends far beyond their immediate surroundings. The shock waves and radiation produced by cosmic rays can ripple through the galaxy, influencing the evolution of star systems far from the nebulas they originate in. In this way, cosmic rays are not just fleeting phenomena, they are cosmic architects, their influence shaping the universe in ways that are still not fully understood. Yet, cosmic rays aren't the only invisible force shaping nebulas. In some of the most dynamic regions of space, another powerful influence takes center stage: magnetic fields. These unseen forces, though less energetic than cosmic rays, play a crucial role in sculpting the gas and dust of nebulas into the intricate structures we admire. From twisting filaments to delicate loops, magnetic fields leave their mark on the fabric of space, reminding us that the universe is as much about the unseen as it is about the visible. As we turn our attention to these magnetic nebulas, we'll uncover another layer of the universe's incredible complexity, where invisible forces work in harmony to create the glowing clouds that light up the night sky. The interplay between magnetic fields and nebulas is a story of order and chaos, a reminder that even the most delicate structures are shaped by forces far beyond our control. Magnetic fields are the unseen architects of the cosmos, weaving their influence through the vast clouds of gas and dust that form nebulas. While we often marvel at the vibrant colors and glowing structures of these celestial wonders, it's the invisible force of magnetism that shapes their most intricate and dynamic features. Imagine these fields as cosmic threads twisting and stretching through space, guiding the flow of gas and dust into elaborate patterns. They are the hidden hands behind the delicate filaments, swirling loops, and towering pillars that define so many of the nebulas we admire. Take, for instance, the intricate tendrils seen in the Veil Nebula. These delicate, lace-like structures aren't just the result of shock waves from a supernova explosion, they're also shaped by the magnetic fields threading through the gas. These fields act like invisible scaffolding, channeling and organizing the flow of material into the stunning patterns we observe. Without them, the nebula's chaotic aftermath might have formed a far less structured and far less beautiful remnant. But magnetic fields do more than just create aesthetic patterns. They also play a critical role in regulating the movement of gas and dust within nebulas. In regions where stars are forming, magnetic fields can slow down the collapse of gas clouds, acting as a kind of cosmic brake. This process allows the gas to clump together more gradually, forming denser cores that eventually ignite into new stars. In this way, magnetic fields are not just passive bystanders, they're active participants in the birth of stars and planetary systems. Studying these magnetic fields, however, is no easy feat. Unlike gas and dust, which emit light we can observe, magnetic fields are invisible, leaving no direct trace for telescopes to capture. To detect them, astronomers rely on indirect methods, such as measuring the polarization of light emitted by the nebula. This technique reveals how magnetic fields align the dust particles, offering clues about their strength and direction. Yet, even with these tools, mapping the magnetic fields within nebulas remains a complex and often painstaking process. The challenges don't end there. Magnetic fields in nebulas can be incredibly turbulent, twisting and shifting in response to the forces around them. This turbulence creates environments where gas and dust are constantly being reshaped, making it difficult to predict how a nebula will evolve over time. Despite these complexities, understanding magnetic fields is crucial to unraveling the mysteries of how stars and planets form, as well as how nebulas themselves come to life. As we explore the role of magnetic fields in shaping nebulas, it's worth considering how these invisible forces interact with other cosmic influences. One such force, equally powerful but far more dynamic, is the stellar wind, torrents of charged particles streaming from the surfaces of massive stars. These winds, often shaped by the very magnetic fields they originate from, carve out vast cavities in the surrounding gas and dust, sculpting nebulas into breathtaking and often chaotic forms. The interplay between magnetic fields and stellar winds is a story of creation and destruction, where the forces of nature work together to shape the cosmos in ways that are as beautiful as they are complex. As we turn our attention to these wind-sculpted nebulas, we'll see how the universe's most dynamic processes continue to shape the glowing clouds we admire, weaving a tale of energy, transformation, and the delicate balance that governs the cosmos. Stellar winds are the universe's invisible sculptors, vast streams of charged particles that flow from the surfaces of massive stars at incredible speeds. These winds don't just drift aimlessly through space, they collide with the surrounding gas and dust, carving out intricate shapes and structures that define the nebulas we admire. Imagine a star so powerful that its energy doesn't just radiate as light, but also propels material outward with enough force to reshape entire regions of space. That's the power of stellar winds, a force that both creates and destroys, shaping the cosmos in ways that are as beautiful as they are hazardous. Take the Carina Nebula, for example. This colossal star factory, home to some of the most massive stars in the galaxy, is a prime example of how stellar winds shape the universe. The intense radiation and winds from stars like Eta Carinae blast through the surrounding gas, carving out vast cavities and towering pillars. The process is both creative and destructive. On one hand, these winds compress the gas, triggering the formation of new stars, On the other, they erode existing structures, stripping away material and leaving behind a landscape of sculpted gas and dust. But the influence of stellar winds doesn't stop at shaping nebulas. It also creates hazards for nearby star systems. The high-energy particles streaming from these winds can bombard planets, stripping away their atmospheres and exposing their surfaces to harmful radiation. For any planetary systems unlucky enough to be in the path of these winds, the consequences can be devastating. It's a reminder that the universe, for all its beauty, is also a place of immense power and volatility. Another striking example is the Eagle Nebula, home to the iconic pillars of creation. These towering columns of gas and dust, immortalized by the Hubble Space Telescope, are being slowly eroded by the stellar winds of nearby young stars. The intense radiation and winds chip away at the pillars, creating the intricate shapes we see today. Yet, even as these winds destroy, they also create. The pressure from the stellar winds compresses the gas, triggering the birth of new stars within the pillars themselves. It's a cosmic paradox where destruction fuels creation, and the forces that tear down also build up. Stellar winds remind us that the universe is a dynamic, ever-changing place, where the forces of creation and destruction are locked in a delicate balance. These winds don't just shape the nebulas we see, they also drive the evolution of the cosmos, influencing the birth of stars, the formation of planetary systems, and the fate of entire galaxies. Yet, stellar winds aren't the only forces that leave their mark on nebulas. Across the universe, another powerful influence takes center stage: supernova remnants. These glowing clouds of gas and dust, born from the explosive deaths of massive stars, are shaped by shock waves and radiation that ripple through space with unimaginable energy. As we turn our attention to these remnants, we'll see how the universe's most violent events continue to shape the cosmos, weaving a story of creation and destruction that spans billions of years. Supernova remnants are the universe's grand storytellers, glowing clouds of gas and dust that mark the explosive deaths of massive stars. These cosmic graveyards scattered across the galaxy are more than just breathtaking sights. They are windows into the life cycles of stars and the forces that shape the cosmos. When a star many times more massive than our Sun exhausts its nuclear fuel, it doesn't fade quietly. Instead, it collapses under its own gravity before rebounding in a cataclysmic explosion, a supernova. The shock waves from this event ripple through space, tearing through the surrounding gas and dust, compressing it into intricate, glowing structures. These remnants are both monuments to destruction and cradles of creation, offering a glimpse into the universe's relentless cycle of birth and death. One of the most iconic examples is the Crab Nebula, the aftermath of a supernova observed on Earth in the year 1054. Located about 6,500 light-years away, this swirling cloud of gas and dust is a testament to the immense power of stellar explosions. At its heart lies a pulsar, a rapidly spinning neutron star that emits beams of radiation, energizing the surrounding nebula and giving it its distinctive glow. But the Crab Nebula isn't just a beautiful remnant, it's also a cosmic laboratory. By studying its filaments and shock waves, astronomers can piece together the story of the star's explosive death and the processes that shaped its aftermath. Another striking example is the Veil Nebula, a sprawling supernova remnant located about 2,400 light-years from Earth. This vast, filamentary cloud glows with the light of ionized gas. Its delicate tendrils a testament to the shock waves that continue to ripple through space thousands of years after the explosion. But these shock waves aren't just beautiful, they're also incredibly dangerous. The intense radiation and high-energy particles released by supernova can strip away the atmospheres of nearby planets, posing significant hazards to any star systems in their path. Yet, for all their destructive power, supernova remnants play a crucial role in shaping the universe. The heavy elements forged in the hearts of massive stars, elements like carbon, oxygen, and iron, are scattered into space by these explosions, enriching the surrounding gas and dust. These elements become the building blocks of new stars, planets, and even life itself. In this way, supernova remnants are not just endings, they are also beginnings, seeding the cosmos with the raw materials for future generations of stars and galaxies. But the story doesn't end there. Supernova remnants also provide astronomers with a unique opportunity to study the extreme conditions found in neutron stars and the processes that drive the evolution of nebulas. The Crab Nebula's pulsar, for example, emits jets of particles and radiation that shape the surrounding gas, creating structures that are as dynamic as they are mesmerizing. These remnants remind us that the universe is a place of constant change, where even the most violent events can give rise to new possibilities. As we reflect on the role of supernova remnants in shaping the cosmos, it's worth considering how these glowing clouds fit into the larger story of the universe. They are not just graveyards for dead stars, they are also birthplaces for new ones, places where the forces of creation and destruction are forever intertwined. From the intricate filaments of the Veil Nebula to the pulsar-driven glow of the Crab Nebula, these remnants remind us that the universe is as much about renewal as it is about endings. And as we bring our journey through the cosmos to a close, let's take a moment to reflect on what we've learned. From the birth of stars in stellar nurseries to the explosive deaths of supernova, nebulas are the universe's way of telling its story, a story of creation, destruction, and the incredible forces that shape the cosmos. These glowing clouds, with their vibrant colors and intricate structures, are more than just celestial wonders. They are windows into the universe's past, present, and future. So, the next time you gaze up at the night sky, remember, every glowing cloud of gas and dust is a chapter in the universe's grand narrative, a reminder that even in the vastness of space, nothing is ever truly still. Whether it's the delicate tendrils of the Veil Nebula or the pulsar-powered glow of the Crab Nebula, each nebula tells a story, and it's a story that continues to unfold one star at a time. As we come to the end of our journey through the cosmos, let's take a moment to reflect on the incredible nebulas we've explored, each one a masterpiece of creation and destruction, beauty and danger intertwined. From the vibrant stellar nurseries of the Orion Nebula to the explosive remnants of the Crab Nebula, these glowing clouds of gas and dust are more than just celestial wonders. They are the universe's storytellers, revealing the cycles of birth, life, and death that shape the cosmos. We've marveled at the delicate filaments of the Veil Nebula, a supernova remnant that glows with the light of ionized gas, and stood in awe of the towering pillars of creation in the Eagle Nebula, where new stars are born amidst the chaos of stellar winds. We've ventured into the heart of the Carina Nebula, where massive stars like Eta Carinae unleash unimaginable power, and peered into the haunting beauty of the Helix Nebula, a planetary nebula that offers a glimpse of our sun's distant future. Each of these nebulas is a testament to the universe's dual nature, its capacity for both breathtaking beauty and staggering destruction. They remind us that the cosmos is not a static place but a dynamic, ever-changing tapestry woven together by forces far beyond our control. Whether it's the gentle glow of a reflection nebula or the violent aftermath of a supernova, these cosmic clouds reveal the delicate balance that governs the universe, a balance where creation and destruction are forever intertwined. But the story of nebulas doesn't end with their beauty or their hazards. These glowing clouds also play a crucial role in the evolution of the cosmos. They are the birthplaces of stars and planets, the remnants of stellar deaths, and the carriers of the heavy elements that make life possible. Without nebulas, the universe as we know it simply wouldn't exist. As we conclude, I encourage you to keep looking up at the night sky with a sense of wonder and curiosity. The universe is full of mysteries waiting to be uncovered, and each nebula holds clues to the forces that shape our existence. Whether you're an avid stargazer or just beginning to explore the cosmos, there's always more to discover. Share your thoughts and questions in the comments below. What fascinates you most about these cosmic wonders? To leave you with a final thought, let's turn to the words of the renowned astronomer Carl Sagan. Somewhere, something incredible is waiting to be known. The nebulas we've explored today are just the beginning. The universe is vast, mysterious, and endlessly captivating, and it invites us all to be a part of its story. So keep exploring, keep wondering, and keep reaching for the stars. The cosmos is calling.